what we have seen so far in the multiple integration, we have given the rectangular region, then how to write the limits. Whenever we have given the general region, then also how to write the limits. Moreover, and in the third case, whenever the region R is required to divide it into the subregions, then how to divide the regions into the subregions and how to write the limits. Now, one more concept we are going to introduce in this video. So let us start with this exercise. The exercise is integration over 0 to 4, integration over minus under root 16 minus y square to under root 16 minus y square. The function is square root of 25 minus x square minus y square dx dy. So first let us discuss, if I try to integrate this integration, then which kind of difficulties we face. As you know, these are the limits of x. So let me write x is equal to, and x is equal to outer limit of y. So I am writing y is equal to. So what I have to do, I have to integrate this quantity with respect to x first. So when I integrate the quantity with respect to x, 25 and minus y square are assumed as constant. So I should have actually the idea about what is the integration of s square minus x square with respect to x. And you know that while we integrate this quantity, the integration formula is not that much simple. Now, if we apply our last idea that I can interchange the integral limits dx dy by dy dx. So suppose I am writing by dy dx, right, by interchanging the limits. Then I have to integrate the quantity with respect to y first. So when I integrate with respect to y, the 25 minus x square is assumed as constant, and so I have to integrate, say, b square minus y square with respect to y. This is what I need to integrate. So both the integral are of the same kind, here with respect to variable x and here with respect to variable y. So suppose I try to solve this integration with respect to dx dy or dy dx. One thing is clear, that in both the cases the integration or the calculation is going to be difficult. So do we have any other mathematical tool so that we can convert this into the easy format and integrate? Right. So this leads to the new idea, that is called changing of variables. We convert x, y into the new variables. Today we shall discuss how do we convert these Cartesian coordinates into the polar coordinates. So now let us start changing the variables. We change the Cartesian coordinates into polar coordinates. You know, x is equal to r cos theta, y is equal to r sin theta, where r is under root of x square plus y square and theta is tan inverse y upon x, and this is the range of theta. This is theta minus pi less than or equal to theta less than or equal to pi. Now see, what we are doing in the Cartesian coordinate. Suppose we have given this is the xy plane, then in Cartesian coordinate we measure with the horizontal line as well as the vertical lines, right? So by increasing the length and width of the rectangle, we try to cover whole xy plane. So this is small rectangle, then we can make it large, again large, again large, and this is how do we cover whole xy plane. Now see, in polar coordinates, that is r and theta coordinates, how do we cover the xy plane? So suppose I draw the circle with center 0 0 and say radius 1. So this is the circle. Now I draw another circle with the same center, say radius 2. So this is the circle. Now suppose I draw the circle with radius 3, and so in this way I increase the radius. R is equal to 1, 2, 3, 10, 100, 10,000, and this is how we cover whole xy plane. So here what we are doing, we are increasing the radius, and in the circle we have given the angle from 0 to 360 degree, or as mentioned here minus 180 degree to 180 degree. Right. So in the Cartesian coordinate, we are covering the xy plane using horizontal and vertical lines. Whether here we are covering the xy plane using the radius and the angle. Now suppose this is my region R. Then using x and y coordinates, how do we write the limits? Either with respect to y first, then we draw the vertical line and we write the equation of this, and we write the equation of this, then using the horizontal lines we write the limit of x, right? But now with respect to polar coordinates, how do we write the limits? We know that our region lies in the first quadrant, right? So suppose I try to cover the region using the circles, right? Then this is the radius r is increasing in this way, and so this is the radius r fixes the circles, so I have to collect the circles from these to all these circles, from this circle to all these circles, right? Now the angle fixes the portion. Theta equal to 0 to theta equal to 360 degree covers for all the quadrants, right? Now my region starts from this line. So this is theta equal to 0, and I have to cover theta equal to 0 to till this theta, this one. This is theta equal to pi by 2, right? So here my radius starts from this point and goes to this point, and theta starts from positive x-axis, which is theta equal to 0, to this. Clear? So this is how do we write the region in terms of r and theta. Let us work with this particular exercise, which clears the idea more. As usual, what is our first task? We find out the curves, we draw the curves, we find the region, right? And then we write that region in terms of r and theta. So let us discuss. So here our curves are, see, you know that this is the limit of x and these are the limits of y. So what I have given, y is equal to 0 to y is equal to 4, and another one is x is equal to minus under root 16 minus y square to x is equal to under root 16 minus y square. So y equal to 4, y equal to 0, y equal to 4 are the obvious curves. These two are lines. Next, which curve is this? So let us take square both sides. So this is x square is equal to 16 minus y square, and therefore x square plus y square is equal to 16. For this also, let us take square both sides. So x square is equal to 16 minus y square, and therefore x square plus y square is equal to 16, right? So both the curves, this one and this one, are same. So total 3 curves I have, y equal to 0, y equal to 4, and x square plus y square equal to 16. So let us draw these curves first. We have the curves, y is equal to 0 is which line? This line, y equal to 0. So let me mention with the other color. X-axis, the line y is equal to 0, then line y is equal to 4 is this line, y is equal to 4. Clear? This is y equal to 0 to y is equal to 4. That means my region lies in this horizontal strip. Now what we have given? Circle x square plus y square equal to 16 to the circle x square plus y square equal to 16. So if you observe the lower limit, then x is equal to minus and x is equal to plus, right? So actually it fixes this thing. Equation of this portion, this is what? X is equal to minus under root 16 minus y square, and equation of this portion, x is equal to plus under root 16 minus y square, because in this quadrant x is negative, in this quadrant x is positive, right? So what is my region? My region is this portion, this horizontal line and upper half circle, that is my region. So our region R is this horizontal line and upper half circle. This is our region R. Now what I am doing, I am not going to solve this integration by our usual integration method. We convert this dx dy in terms of dr and d theta. Now see, when we convert double integration over r f of xy dx dy in terms of, so here we have given the region R in terms of xy plane, right? Now we convert our xy coordinates into r and theta. So what we are substituting, f of what is x, r cos theta, y is r sin theta. Then in place of dx dy, what we write, it is not only dr d theta, right? In place of dx dy, we have to write r dr d theta. So this thing you need to memorize, dx dy will become r dr d theta. Why dx dy becomes r dr d theta, that we shall discuss in the next video, right? Right now I am not going to reply why dx dy becomes r dr theta, but in place of x we write r cos theta, in place of y we write r sin theta. So dx dy will be converted into r dr d theta. In general transformation, right, why it becomes this, that we shall discuss in the next video. But for this video only you need to remember that dx dy will be converted into r dr d theta. 25 minus, what is x? X is r cos theta, so it is r square cos square theta minus, what is y square? R sin theta, so it is r square sin square theta, and then dx dy becomes r dr d theta. So I am writing r dr d theta, right? So this thing is clear. Now what I have to write? I have to write the limits of r and theta. So I write inner limit of r and outer limit of theta. Theta is equal to, right? Now here one thing is fixed, that I always write inner limit of r and outer limit of theta. Why? I know that outer limit is always constant, and theta is what? Theta is only the angle which is always constant, right? So I always write theta as the outer limit and r as the inner limit. Now the question is, what is r in our case? So look at the region. What is the region? My region r is this, right? So actually what I have to do, I have tried to cover all these my interior points. I have tried to reach to all these points. So how do I reach? I start with radius 0, right? So I start with the origin, I draw the circle with very small radius, then circle with little bit large radius, then again the circle with large radius, then again I draw the circle with the large radius. So actually I have started with the radius r is equal to 0 and I am increasing this radius, right? Now I have to reach till this, the outermost circle is this, right? This one. So can you tell me what is the equation of this outer circle? This is x square plus y square is equal to 16. What is x square plus y square? is r square. So r square is equal to 16. So r is equal to 4. Right, that means equation of this circle is r is equal to 4. So what I am doing, I am collecting the circles starting from r is equal to 0 to r is equal to 4. So the range of r is clear, r is equal to 0 to r is equal to 4. Right, now when I collect only the circles, it fixes whole thing, but I have to concentrate only on the upper half. How do I fix my upper half? So suppose I am starting with theta equal to 0. So this theta equal to 0. Now I take theta equal to 1 degree, theta equal to 2 degree, say theta equal to 30 degree. So I am collecting all these points. Theta equal to 1 degree, theta equal to 2 degree, up to theta equal to say 30 degree, theta equal to 45 degree, theta equal to 60 degree, theta equal to 90 degree, theta equal to 90 degree, then 100 degree, then 110 degree, till this. Right, I am collecting all the theta to theta is equal to 180 degree. Right, so starting from theta equal to 0 to theta is equal to 180 degree, which fixes only this half circle. Clear? And so what is my theta? Theta is equal to 0 to theta is equal to pi. So this is how do we write the limits in polar coordinates. R equal to 0 to 4, theta is equal to 0 to pi. What is the integral quantity? 25 minus r square cos square theta minus r square sin square theta. So now our next step is theta equal to 0 to pi, r is equal to 0 to 4 under root of 25 minus r square, because cos square theta plus sin square theta is 1, into r dr d theta is under root of 25 minus r square. Now what is the derivative of 25 minus r square? Is minus 2r. Right, if I have given this is function f, its square root into its derivative f dash, then what is the integration? This is nothing but f raised to 3 by 2 divided by 3 divided by 2, which is nothing but 2 upon 3 f raised to 3 divided by 2. Clear? So 25 minus r square and its derivative is minus 2r. Here we have 25 minus r square into only r. So first we convert into the desired quantity and then we apply this formula. Integration theta equal to 0 to pi under root of 25 minus r square, this is say minus 2r, so I divide by minus 2, then dr d theta, which is equal to, by using this formula let us write this minus 1 upon 2 as it is, 2 upon 3, 25 minus r square, so 25 minus r square raised to 3 upon 2 with the limit of r is equal to 0 to r is equal to 4, and whole integration with respect to theta equal to 0 to pi d theta. Clear? Now let us substitute the values of r. So this is, you can cancel out 2 and 2. So this is minus 1 upon 3 integration theta equal to 0 to pi, when r is equal to 4, 25 minus 4 square is 16. So 25 minus 16 is 9, 9 raised to 3 upon 2 minus, when r is equal to 0, it is 25 raised to 3 upon 2 and d theta. This is equal to minus 1 upon 3 So first, what is square root of 9? Is 3. 3 cube is 27 minus, what is the square root of 25? Is 5. 5 cube is 125. Then this is the constant quantity. So now what is the integration of the constant with respect to theta? Is theta. And then theta is equal to 0 to theta equal to pi. And so this is equal to minus 1 upon 3 into 27 minus 125 is 98. Minus 98 actually it is. So minus minus plus. So 98 divided by 3. And the upper limit theta equal to pi, lower limit is 0, which is 98 upon 3 into pi. This was the exercise. We observe that it is very difficult to evaluate this integral with respect to x or y direct. So what I do, I have converted x and y in terms of r and theta. When we convert xy in terms of r and theta, my dx dy will be converted into r dr d theta, and using under that transformation how we have written the limit of r and theta, and then we solve the integral.